Proximity fuses blast fragments into the air to take out drone swarms. Hi, I'm Chris. You joined the next version of the Counter Drone series with both Warrior and the C-UAS Hub, which is a British think tank devoted with experts to counter drone experts. We have today, speaking of experts, doesn't get much better than this, someone who knows specifically about ammunition, about the drone threat. We are joined by Mr. Ben Harris. He's the executive director of the National Armaments Consortium. That's quite significant. It's an entity that puts academia in a collaborative way together with government, customers, and industry to kind of meet the needs for industry. So Mr. Ben Harris knows ammunition, knows the operational need for ammunition like very few. And we want to welcome him and say thanks for talking to us and bringing your expertise, which is amazing.
Thanks for having me.
Absolutely. Well, let's start with this demand for proximity fuses. I actually learned that from you. It's one way to kind of do the area detonation. You can kind of counter drone swarms. How and why is this being in such demand?
So first, all UASs we have to go with a multi-layered approach. So you have your high-end missiles, your high-end, more exquisite systems that can target your larger drones. But as you get closer and closer to the front edge of the battlefield where the majority of the soldiers are, you cannot afford to have lasers everywhere or Patriot systems everywhere. You can't count on the Air Force has counter UAS capability, but there's only so many weapons you can carry on a plane, and if they're off station, it comes down to that last line of defense. And that last line of defense is where proximity fusing, similar to World War II, can again turn the tide and save London, so to speak. You can put these in your 40 millimeters that are already fielded, the 30 millimeter systems that are already fielded, the 25 millimeter systems that are already fielded. We can incorporate advanced proximity fusing and give it multi-capability. And that's the last line of defense before these UASs come in and kill our soldiers.
Excellent. Well, I wanted to ask you about some of the technical elements of this, given your technical expertise seems quite excellent and far-reaching. From what I understand, the delayed fuse can be a proximity fuse. It can use a laser rangefinder to identify an area, get to a point in space, a predetermined point in space to a degree, and then detonate in an area. How is that working, and where are some places that's in demand and going to be put?
Well, there's two ways it can work. One is you can have a time fuse. So if you have a laser and you can know the exact spot that the UAS is going to be in, then you can just set a timer and have the round detonate. Proximity fusing is a little bit different. In other words, it's looking for a target in the air, and when it sees it, it just goes off. So you just have to get it pointed in this general direction of where the UAS is, and then it'll detonate before it hits it. And that's the beauty of proximity fusing. Lasers work, but they don't work all of the time right now. So there's a lot of ways to defeat lasers. So proximity fusing, that's the key, the sweet spot that we see.
Excellent. What kind of sensor does it use to know that it's near a target and can then detonate?
It's basically radio. It's basically like a radio. I don't want to get too into the weeds because then we start getting out of distro A kind of stuff. But it basically senses where the target is by sending out a signal and getting that feedback. And when it knows it's close enough, then it can go off.
That's excellent. In our conversation, we were talking about the Stryker, the Bradley, the Apache. What are some platforms that this would integrate with, and what are some recent developments in terms of where the demand might be coming from?
So we've had proximity fusing for a long time. Just to be clear, it's been in artillery. Like I said, it was developed during World War II. It turned the tide for the Battle of London. It saved us at the Battle of the Bulge, but now it's back again. You can put it in the CROWS system, and there was a system that came out recently in support of Ukraine. It was called at first the agnostic gun truck. Later, it was called the MACE system. But basically, and there's been some recent news about it. You take like a CROWS-like system, a common remotely operated system that has the optics, has the sensors, it has the cradle and the weapon ammunition carrier. You can put in a 40 millimeter in it, or you can put a lightweight 30 millimeter in it. And you could basically put it on a skid, and you can slide it into the back of an F-250 or a Chrysler or a General Motors pickup truck, and you can drive around the battlefield. You can have another vehicle with more advanced sensing capability, because first you have to detect it, which also is technology that we see coming through the NAC right now, all the way from the high end, all the way down to the low end. But you can slide it into the back of the truck, and these were being developed and being sold to the Ukrainians. So that kind of fusing technology, we can now put it in a 40 millimeter. It's going in the Bradley, and that's really an all-weather capability that's most affordable. Unfortunately, it is closer to the soldiers. It'd be ideal to take them all out 10 kilometers away. But if you have to wait or you don't have that capability, then your last line of defense is these 1 to 5 kilometer shots with these smaller caliber weapon systems.
10-4. This is my last question on proximity ammo, and then I want to ask about NAC because that's so central to how this kind of process works. But I understand we both showed up at the Bushmaster User Conference in Kingman, Arizona several years back, where that kind of targeting was practiced with the 30 millimeter shots, back of a pickup truck, Strikers, Bradleys. How is that networked in terms of fire control with radar, ISR, and different kinds of RF connectivity with fire control in terms of firing those proximity fuses and that ammo to the right spot, identifying it with the right target?
Well, the queuing right now is basically it can be, the collection can be done through the command and control system. So first you have to detect it. So it can be done with radars. It can be done with optics. The Air Force has the capability. The Navy has the capability. The Army has the capability. From the high end, for example, the new radar that's replacing the radar for the Patriots, the LTAMDS radar. That was a prototype developed through AMTC, the consortia that is part of the NAC out of the Redstone Arsenal. But first you have to detect it. Then they're going to use command and control systems that are going to tie all this information in. But at the end, it's going to be a soldier who's going to be getting the cue, who's going to say, okay, that's a threat. I'm going to go after it. But the command and control system has to make sure that they don't send the same threat message to all the vehicles, and you have 5 vehicles essentially wasting ammunition, taking out one target. So the command and control is going to divvy that up to who's closest to it or who has the best opportunity to take that target out. That's kind of the role that we see coming on now with artificial intelligence, kind of accelerating that. Whereas right now, a lot of the command and control systems, that there might be one system that does one thing and there's another one there. And getting those two systems to talk together is where you're seeing a lot of the advancements in command and control that's going to speed that queuing and that kill chain, speed that up.
Well, Roger that. I want to ask about AI, but first, help me understand the NAC role, the NAC, and part of what you're involved with, from what I understand, is cutting edge efforts to streamline the acquisition, to identify those technologies that are most in need and how to deliver them quickly. A big Pentagon effort right now. That very effort is fundamental to what NAC does, sir. As you know, being the director, what can you tell us about what NAC is doing with improving OTAs and things like that?
So first we start with collaboration. We exist to support the government. So when the government has a requirement, be it from Picatinny Arsenal, Indian Head, or from Redstone Arsenal, we support those collaboration events. So we set up the venue for those, we advertise it, we basically run the event for them so that it's basically easy for the government. The government, though, has all the requirements. So the government shows up, and the government solicits those requirements through the NACS portal, which we control, which allows us to share distribution D information. So if you go to sam.gov, it says go to bids, which is what we run. It's just a higher level of security so that they can get the requirements out in a more secure environment. We run that for the government. So that's the key. And the reason that's key is the law requires non-traditional participation, or it requires the larger companies to pay a third of the developmental cost. So they're motivated to look for non-traditionals. So what we do is we find the non-traditionals out there, mostly small businesses. Over 76% of our membership, we have 1,200 plus members, 76% of them are small businesses. So the beauty of the other transaction authority is to go fast, but it requires non-traditional participation. So what the NAC does is we bring a huge pool of non-traditionals that are focused on armaments and ammunition. So it's kind of a perfect marriage. The government has armaments and ammunition requirements. They bring them to the NAC, who has a lot of armaments and ammunition members, and the majority of them are small, non-traditional businesses. So it fits perfectly in with the law.
10-4. Now, how are you tracking this with finding the emerging technologies? Because a lot of primes do their own R&D to find requirements that they then offer to the military services to close a capability gap or meet a requirement. And then, of course, there are startups and smaller innovators pushing the envelope to come up with new solutions that might not have a precedent. How are you helping to balance that mixture and find these really valuable innovations?
Well, we call it speed dating, but what we do is the small businesses, they don't have the resources, the funding to basically go to all of the large companies and show them their innovation, their technology. They have it. They've developed it on their own. They want to build it, they want to make some money. They need to take care of the kids. But how do they do that? How do they get the introductions to those? And that is what we do. So when we host a collaboration event, either it be a live collaboration event or a virtual collaboration event, it's free to all of our NAC members. So we'll set up the venue at a hotel for 3 days or 2 days or whatever it is, and they can come. Now, we don't pay for their travel and their hotels, but they come if they're a vetted NAC member that still has a good standing on their distribution D capabilities, and they can do what we call speed dating. So they can meet with the government and they can show the government their innovative technology. At that point, the government can actually modify under the other transaction authority their requirements. Once they've advertised them, they can kind of be tweaked based on what they see from industry. But it also gives the smaller businesses an opportunity to show the larger businesses. And the larger businesses, again, are motivated by the law to look for non-traditionals. So that's what we're doing is we're marrying up these innovative, non-traditional companies that are all US based, because you have to be US based to be a NEC member, with the larger companies. They're looking for the competitive advantage, and we help sync them up.
Oh, that's excellent. That's excellent. Well, now, given this, I wanted to ask about AI and some of the applications because there's so much innovation and kind of next generation, potentially paradigm changing applications of AI, particularly with sensor to shooter pairing. There are instances where an incoming sensor feed can be bounced off a database and the optimal connection can be made between what is the target verification, what effector or countermeasure is best suited for that. Can proximity fuses help verify targets by using the RF or connecting networking in with some data link to a censored system to an AI database to verify those targets to ensure the reliability?
Well, that's a size, weight, and power problem right now. The sensor, there is sensors that I had seen recently, very innovative sensors that can do that. They have all of the data, a huge database on some small NVIDIA GPU processors. They can go through very quickly at imaging and on all of the spectrum that's not just visible, but invisible spectrum. And they can tell you that's a bird or that's a UAS. So the key isn't in the prox fuse. The ability to miniaturize all of that and put that into a prox fuse, especially when we're talking 25 millimeter or 40 millimeter, that technology is years away. But the sensors can do it. And you don't need that, and they're expensive. So you don't need that in a prox fuse. What you need is affordable prox fused medium caliber rounds linked in with a command and control system with a really smart sensor that can see that. You got to protect the sensor. And again, that's what all these systems can do together collaboratively.
10-4. Last question on this. How is the round itself with the area proximity fuse, the RF signal, as you pointed out? How is that networked with the host vehicle to a degree? Is the target and the trajectory verified prior to launch or in flight?
There will have to be some hardware changes made to the systems. For example, some of the vehicles, they may only have a switch that allows you to go from high explosive to armor piercing. So they're going to have to pull that unit out. They're going to have to put in a new unit that gives it the ability to select a third round. Um, so that's something that's going to have to be done. But again, proximity fusing If you can get it out of the gun, from that point on, it's kind of on its own. It's looking for something. So again, if you go back to what I was talking about, the layered defense, you can't use proximity fusing everywhere. For example, not that we have, and I don't want to freak anybody out, but we don't have gun systems today guarding our nuclear sites in the United States. And you can't, because where's that round going to go if it's a dud? You can't make something 100% reliable. So every once in a while a round lands, hopefully in a safe spot, but you can't use them in our neighborhoods and our communities. I'm talking about stuff on the battlefield to protect soldiers. So a lot of the capabilities and the technologies that being developed that doesn't have that problem, those are other counter UAS technologies that we have to have. We can't just rely on prox fusing. We have to rely on this whole idea of a layered defensive system to protect the homeland and our soldiers.
10-4. I'm glad you mentioned layered system, because it calls to mind that NAC, from what I understand, is very joint. And when one thinks proximity fuse, that pertains very much to 5-inch guns on a Navy warship. That was a factor, from what I understand, talking to the commander of Carrier Strike Group 2, countering some of the Houthi attacks in the Red Sea, that there's very much a naval surface warfare application. You think small boats, and then, of course, potentially even some kind of air-to-air drone defense.
Absolutely. I mean, then that's, my background coming from a joint program executive office. So that office is the single manager for conventional ammo. So the idea that the Department of War had years ago was, well, let's have one organization kind of find best of breed, the best technology, and that could be shared throughout the Army, Air Force, Navy, and the Marine Corps. So a lot of the 30 millimeter systems that we're talking about, they're on Air Force planes. Those same munitions are on Special Forces, C-130s, and you can put them on Strykers, Crows. There's Crows versions for the Navy for close-in defense. Similar Crows systems on a lot of our vehicles.
Roger that. Roger that. Well, last question. I wanted to ask you this: given the progress and the mission of what the NAC is up to, how far along, what kind of progress are you making, and what comes next in terms of how NAC can help expedite this process? It's a big push with the Pentagon right now: rapid acquisition, identifying those needs, helping to deliver them. You play clearly a really critical role with that. What comes next? What project are you making? And I think that'll wrap us up, unless I could talk to you all day, but please go ahead.
Well, I want to give you an example. So years ago, there was a rocket and a mortar problem on a lot of the forward operating bases in Afghanistan. And there was no real way to shoot them down as they were coming in. So when you think about counter UAS, think about a mortar round coming on our forward operating bases. So there was a requirement that came out through the NAC. It was solicited. The proposals were collected. A contract was awarded, and the first prototype was delivered all in 12 months. That's the speed that they're looking for. So we have done this. We have done this before. But as we got bigger and bigger and bigger, the FAR creeped kind of in, and the process got slowed down to where just to get it on contract, we saw award timelines taking too long. We're about innovating and getting it into the hands of soldiers. So we have been the squeaky wheel, kind of saying we can go faster, and look at how slow we're going now. We started to turn the tide, and since 9 April, when the executive order came out about OTAs, we have seen nothing but the entire community kind of come on board with the new mantra is it's all about speed, it's all about speed, it's all about schedule, then it's about performance, and the last thing is about cost. So they kind of flipped it, which is great news, which is what, we were just saying we can go faster. We just have to stick to the principles that we have. So we're already seeing some award times that are speeding up. And I think all of the messaging coming out of this administration is fully in support of what our industry members want, which is when we write a white paper, we want to see it get put on contract quickly so we can start innovating instead of haggling over a couple of words in a contract.
Roger that. Well, you heard it here from Mr. Ben Harris, Executive